symmetry. If you notice symmetry in a function, that can make life easy because you only have to draw half of it and then do a reflection or whatever the symmetry happens to be. So there's things, odd functions. The definition of an odd function is that function negative x is equal to the negative of function x. Now if you rewrite that, it's what we just saw. Because I could rewrite that as function x equals negative function negative x. Rotation 180 degrees. So this curve, if it has point symmetry about the origin, then you've got an odd function. In other words, if you were to rotate the curve 180 degrees and you get the exact same shape, you've got an odd function. So looking at the four basic ones on the wall there, well, the parabola's no good. If I was to rotate that 180 degrees, I get a different shape. The cubic's okay. Rotate that 180 degrees, I get the same shape. The hyperbola, if I was to rotate that 180 degrees, I'd get the same shape. What about the circle? Would that one be an odd function? Hands up for yeah, that would be an odd function. Hands up for no, it wouldn't be. Why not? You're right, but for the wrong reason. It's not an odd function because it's not a function. Remember, the circle is not a function, so it can't be an odd function if it's not a function. Right. But you are right. Everyone that said yes for the rotation, certainly if you rotate at 180 degrees, you are getting the same shape. So spin at 180, it looks the same. So y equals x cubed, 1 on x. X to the power of 7 minus x to the power of 5 minus 3x to the power of 9. All of these are odd functions. Basically, all the powers are odd. It sort of ties in with odd functions. If you look at it and go, oh, look at that, all the powers are odd. It's an odd function. So if we wanted to prove it's an odd function, it's not good enough to say, oh, look at that, all the powers are odd. You have to prove that definition. So write down what function x is. X cubed plus x to the 7. Write down what function negative x is. And then you compare the two. And I can now see, hang on, this is the negative of the first one. That is negative function x. So that is an odd function. That's how you would prove something is odd. Well, if we have odd functions, logical we have even ones as well. It also has symmetry. These are the ones that have line symmetry. So the y-axis is an axis of symmetry. So back to our shapes there. Now we've got the parabola, y equals x squared. That has a nice axis of symmetry on the y-axis. That's an even function. What about the circle? Would that be an even function? It seems to have symmetry on the y-axis. Hands up for yeah, that's an even function. Very good, we're learning. Hands up for no, it's not. It's okay, you can be confident. Remember, not a function. Not a function, can't be it's not an even function either. Examples, x squared I just said, x squared plus 4, minus 3x, 6 plus 2x, 4, minus 27x. All the powers are now even. I'm using a very loose definition of even here because the constant number here. Technically that 4 is 4x to the power of 0. Is 0 an even number? Well, yeah, it satisfies the definition of an even number. You can divide it by 2. So, as I say, very loose definition of even there. Let's prove it's an even function. I do it exactly the same way as that odd one. There's function x. There's function negative x. Let's work this one out and compare. If I square negative x, I'll get x squared. Oh, look, they are the same. So if they're the same, that's an even function. That's how we would prove it. That'll do it.